Hi folks, we're going to take a look at solving exponential equations. Now, back in grade 11 you were limited to only certain types of equations, but now that we've got logarithms we can solve a wide variety of problems. Okay, so let's start with number 1 here. And I'm actually going to solve this problem doing it the way you would have done it last year. And the reason why you can do that is if I look at the bases here, now notice here I talk about 8 as a base because this can be seen as 8 to the 1/2. Okay, and I see that both sides of the equation can be written using the same base. Okay, so here I can write 4 is 2 squared, okay, to the 3x, and here I can write 2 cubed all to the 1/2. And then using our exponent laws, okay, here power of power, I can write this as 2 to the 6x, and I can write this as 2 to the 3/2. Okay, and now I've got two equal powers, and since the bases are the same, the exponents must also be the same. So that means that 6x has to be equal to 3/2, and so here x is equal to 3/2 times 1/6, or divided by 6. Okay, and we get that x is equal to 1/4. Okay, so this is perfectly fine if you can manage writing both sides of the equations as a power using the same base. Unfortunately, as we'll see, that's not always the case. Okay, so we're going to take a second approach here, and we're going to see how we can use logarithms. Now, actually, there's two ways we could do this. Okay, so one way, if you wanted to find an estimate for an answer here, is you might just use log base 10. Okay, and what we saw here is that you can take the log base 10 of both sides. And the reason why that's useful is that you can now use the ski-slope rule to bring down that 3x. So 3x log 4 equal to log of root 8. And so x is just equal to, I'm going to divide out the 3 and the log 4. So log root 8 over 3 log 4. Okay, now this is great because I can just stick this into my calculator and get an estimate, and in fact presumably I would get exactly the same thing, 1/4. Okay, so let's take a look at another option. Okay, and if I'm not necessarily interested in getting an approximation, well, a slightly easier way to do this is to take log base 4 of both sides of the equation, because when I take log base 4 of 4 to the 3x, so I've got a function and its inverse. So notice here I'm going to try to avoid writing that out. We've seen it a few times. So if I take log base 4 of 4 to the 3x, I'm just going to be left with 3x. And then of course I have to take log base 4 of the other side. And so x is equal to log base 4 of root 8 over 3. And if you think about it, these are equivalent, since if I were to apply the change of base formula to this expression, remember what the change of base formula is. So I take the logarithm of the new base of the original input over the logarithm new base of the original base. So it'd be log root 8 over log 4. Okay, and then the divided by 3 gives me something equivalent. Now, at this point here, I would even expect you could just stop here, although I would hope that if you were able to write both sides of the equation using the same base, that you would use this method here. It's kind of like solving a quadratic by factoring. Okay, it's always nicer if you can do that than using the quadratic formula. Okay, the question is how could I solve this to get the 1/4 without my calculator? Now, this side here, not too obvious, but I look here and I see log base 4 of root 8. And this is where I might think, hey, again, why don't I take this, okay, and turn this into base 2, which I can do with my change of base formula, and then hopefully I'll be able to work with root 8. So you could also say I'm going to change this to log base 2. So log base 2 of root 8 over log base 2 of the original base, which is 4. Okay, and don't forget that you've got that 3 also in the denominator. And then from here, well, here, log base 2 of root 8. Root 8, remember, is 2 to the 3/2, like we saw earlier. So 2 exponent 3/2 gives me root 8. So I have 3 over 2 in the numerator. And then here in the denominator, log base 2 of 4. Well, 2 squared is equal to 4. So I've got just 2. And here, the 3's reduce. I'm just left with 1 over 4. Okay, so in fact, we were able to get to this nice answer without using our calculator. Okay, so we see here how important that change of base formula can be. Okay, so that's it for number 1.